To start this chapter, we are going to talk about work and power. So, to get us started, we need to define what work and power are before we start talking about machines. So, work is something that occurs when a force causes an object to move in the direction of the force. Now, that's the key part right here that I want you to pay attention to, is that it's causing an object to move in the direction of the force. Just because you apply a force doesn't always mean that work is being done. There is a chance that if you apply force and it's moving in an opposite direction, work is not being done in that direction. If the object does not move when you are applying a force, that also means that it's not moving, or that work is not being done. So the example I have here is, if you push a car and it doesn't budge, no work is done. You should take a second and think about why you think that might be a thing. So if we look back at the definition, it says work occurs when a force causes an object to move. If you push a car and it does not move, it does not matter if you're applying 100 newtons of force. If that car is not moving, work isn't being done, no matter how much effort you're putting in. So it has to move in order for work to be done. Another part of the work definition is that it has to move in the same direction of the force. So if it moves, but it's moving in a different direction of the force that we're looking at, work is not being done. So if we look at some examples, we're going to determine if these are work or if it is not work. So the first one we have here is pushing a box. So think about, if you pushed a box across the floor, would it be work or not? And it would be, because if you're pushing, your force is, let's say you're pushing it north, your force is pushing north, the box will move north. So that means as long as the box moves, work is being done. Now think about when you have a book bag on and you're keeping on your shoulders and you're walking forward, is work being done on that book bag? And the answer would be no. You have an upward force, and I'm not sure why my markers still can't get my markers to work here, but if you have an upward force on the book bag, your shoulders are pushing up to keep the book bag up compared to gravity. But if you're walking forwards, your force is not forwards, and that book bag is going to move forward also. So if it's not moving in the same direction of the force you're putting on it, no work is being done, even though you're moving it. Whereas the next example, lifting a bag of groceries, if you have a bag of groceries on the floor and you lift it up, the groceries are moving up, so that means it's moving in the same direction of the force. So then it would be work. Now, just walking with that bag of groceries, that is similar to the walking with a book bag on. So you have it in your hands, your force is still pushing upwards to keep the groceries up in the air, but the groceries aren't moving up anymore, they're moving forward with you. So work is not being done because the force is going up, but the groceries are moving forward. So for credit to know that you listened to this, I want you to make sure you write the correct answers next to each of the examples. So pushing a box is a yes, walking with a book bag on is a no, lifting a bag of groceries is a yes, and then walking with the bag of groceries was a no, to help so I know that you're making an attempt to understand this. So we have another equation, yay, for work. So we are going to be calculating work with an equation that is work equals force times distance. So the F stands for force and the D stands for distance. And the units that we use for work is something called joules. So we're going to be doing some calculations with those. And the last thing here is power. So the definition of power is the rate at which work is done. So how quickly is this work happening? To calculate power, we have another equation. Again, yay, something else to add to your equation sheet if you want to do that now or in class later. Power equals work divided by time. So W is what stands for work and T stands for time. So we take work divided by time. How much work are we doing per the amount of time? Our units for this are something called watts. So if you increase the amount of work you do in a given time, let's say you do 10 joules of work in 10 seconds, and then you do 20 joules of work in 10 seconds, well, the 20 joules means you have more power because you're doing more work in the same amount of time. So if you increase your work in the same amount of time, you're increasing your power. But also if you just decrease the amount of time it takes to do the work, so let's say you do 10 joules of work 2 different times, but one time takes you 10 seconds, one takes you 5 seconds, well, the time that took you 5 seconds meant that you had more power at that time. And now we're talking machines, not necessarily humans here. But if you do more work in a time or you take less time to do the work, you're going to increase your power overall.